A hilltop in New Jersey. The setting, giant antennas like monstrous eyes and ears, straining, watching, waiting. Inside the control station, a team of specialists with ultra-sensitive electronic equipment, ready to probe the vast reaches of the sky. These men are waiting for the climax of a dramatic experiment they've been working on for many months in collaboration with the National Aeronautics and Space Administration, an experiment known by its code name as Project Echo. Men like Luke Lowry here, Dick Klahn, Bill Snell, and Bill Jakes, project engineer, all scientists with the Bell Telephone Laboratories. In a few minutes, if things go right, Holmdel will communicate by telephone in a brand new way by routing the call through outer space to Goldstone, California, 2,300 miles away, where scientists of the Jet Propulsion Lab are waiting. This call will be bounced off a man-made satellite. If it works, it will be the first time voice has traveled from the Earth up to a man-made moon and back to Earth again. This is the satellite, a huge empty balloon, here shown while still in its hangar. The inflated balloon is 10 stories high, made of a strong, new aluminized plastic. Strong, yet only half as thick as the cellophane around a package of cigarettes. Its aluminum coating gives it nearly 100% reflectivity. That balloon will soon be hurtling across the sky 1,000 miles high over North America. Yes, these men know why they are on this New Jersey hilltop. But others may wonder, even if it works, so what? Who cares about bouncing messages off a space balloon? What's the practical good of it? We can telephone almost any place in the world today. Thanks to ocean cables, we can talk overseas as if to the phone next door. This year, about 3 million messages will be transmitted across the Atlantic. But 10 years from now, it is predicted there will be 21 million messages. More facilities will be needed. And there are the polar regions where severe atmospheric conditions make radio reception difficult. Here, particularly, the military need for alternate communication systems is great. Powerful microwave transmitters carry telephone calls over barren and open spaces. These systems will always serve us well. But today, as scientists look ahead, they foresee great gaps in our worldwide communications unless more and different systems can be devised. For instance, we would like to see live television programs, history in the making from all over the world. But TV broadcasting presents a special problem. One TV channel requires the space of almost 1,000 telephone circuits. This requirement is simply too expensive for present systems. And even if this problem could be licked today, what about tomorrow? For many years now, Bell Laboratories scientists have been looking ahead to satellites for communication. We are already capable of building a satellite equipped with operating receivers and transmitters, which could be made to operate at a much greater height than a simple reflector balloon like that in Project Echo. The higher you go, the greater the portion of Earth in range of the satellite, and the fewer you need to circle the globe. A worldwide communication system of satellites like this has already been outlined by the Bell system. The plan envisions several strings of equipped satellites, altogether about 50 of them, orbiting at a height of about 3,000 miles. As the one you were using moves out of range, you would switch to the next one coming along, and so on. And if you wanted to send, say, a telephone message or a television program to some area not covered by any single satellite, the signals might be bounced from transmitter to satellite, back to Earth, up to a second satellite, and down to the destination. That way, you could maintain continuous transmission of telephone calls and television programs to various parts of the Earth, But scientists have conjectured even far beyond this. Perhaps someday it will be possible and worthwhile to put up a precisely positioned satellite 22,300 miles out, which at that distance would revolve in step with the Earth and would seem always to hang in the same place in the sky. If it became possible to put 3 such satellites in orbit, together they could cover the Earth. But this high orbit, 22,000-mile system is at best far in the future. As scientists wait in New Jersey and California, today's experimental balloon satellite, the pioneer of worldwide space communications, is already up in the sky, 1,000 miles high, on its first 2-hour orbit around the Earth, hurtling through the vacuum of outer space, ready to relay telephone signals between powerful transmitters and receivers as far apart as New Jersey and California. The men in both locations know that when and if it does arrive, they will have approximately 15 minutes to bounce their messages from coast to coast off its surface. For in 15 minutes it will have swept across the United States and be out of range. These men well know the complicated chain of events that is a natural part of missiles and space operations. Earlier in the day, the first big question was, would the missile system work? Hours before, down at Cape Canaveral, the Delta missile that would put the Echo balloon into orbit was on its launching pad. Ready to be guided through space by the command guidance system, located in the Bell Laboratories control station at the Cape.
Mode control switches.
Less than a minute remains in the countdown.
13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
As the missile hurtles through space, the control center maintains communication with it, checks its position, and automatically sends any necessary steering orders to keep it on its predetermined path. This guidance system was designed by Bell scientists, the same system that meets the precise target demands of the Titan intercontinental ballistic missile. Its job here is to put the Echo satellite in orbit with pinpoint accuracy. Will it? That is the question these men ask themselves as they finish monitoring the guided portion of the missile's flight. And will the balloon, squeezed into a 26-inch sphere, release okay? Will it inflate properly or burst into fragments? They still have to wait. High in the sky, the 3rd stage burns out. The payload section separates from the engine. The protective shell springs apart, releasing the balloon. Floating clear, the balloon is inflated by a chemical powder which instantly vaporizes in the vacuum of outer space. The men won't know it for some time yet, but balloon inflated and in orbit. As the minutes pass, scattered tracking stations take up the difficult job of finding the balloon and tracking it. Now it's up to Bill Jakes and these other communications men in New Jersey and California to find it. When they do, in addition to transmitting tape-recorded messages, they will talk together on the telephone. But until then, they still have their worries. This new, unique horn-type antenna, so painstakingly developed here in Holmdel, will it really eliminate static? It should, with the help of new circuitry and this other recently developed equipment called the Maser. These inventions will make the weakened voice signals come in strong and clear, even after their long journey through space. This is no ordinary amplifying device. It operates in an ultra-cold vat of liquid helium at minus 457 degrees Fahrenheit. In this super cold world, the Maser's ruby crystal helps keep the telephone conversation clear and easy to hear, which makes the Maser one of the greatest new contributions to communications. At last, the sweating out period is about over. Holmdel is in constant touch with Goldstone by an open telephone line. The first actual transmission bounced off a man-made satellite will be from tape recordings. Goldstone has just reported they have picked up the balloon. a pinpoint in the sky, 100 feet wide, 1,000 miles out in space. Like trying to locate a golf ball a mile away.
We have it now, Bill.
Good. Let's hope we can keep it. The signal looks good, Luke. Tracking looks good, too. Let's see how Goldstone is doing. Hello, Goldstone. This is Holmdel. We're getting your signal. How are you receiving ours?
Strong and steady, Bill.
Fine, fine. Okay, here we go. We're going to start our tape now, and you start yours.
This is President Eisenhower speaking. It is a great personal satisfaction to participate in this first experiment in communications involving the use of the satellite balloon known as ECHO. This is one more significant step in the United States program of space research and exploration. The program is being carried forward vigorously by the United States for peaceful purposes for the benefit of all mankind. The satellite balloon, which has reflected these words, may be used freely by any nation for similar experiments in its own interest. Information necessary to prepare for such participation was widely distributed some weeks ago. The United States will continue to make freely available to the world the scientific information acquired from this and other experiments in its program of space exploration.
It really sounds good here, Walt.
Fine, Bill.
And so the first spoken word from man through space to his own satellite and back to man again is the voice of the President of the United States. And as the satellite sweeps swiftly out of range, further transmission must wait for another passage. Now, sometime later, as the balloon again passes over America, the same scientists try the first telephone conversation ever bounced from a man-made satellite.
You can fire up the transmitter.
Right.
Hello, Goldstone. This is Holmdel calling. Calling Goldstone. How do you read me?
Holmdel, this is Goldstone. You're loud and clear, Bill.
Oh, wonderful. Well, it looks like all the hard work was really worth it.
A new, bold stride on a long road has been taken. The road to communications between ourselves and others overseas with the same variety and dependability we now enjoy anywhere in our own country. The balloon satellite of Project ECHO is, of course, for experiment only. But it is an experiment that may result in a new intercontinental communication system. As these men of Bell Laboratories and Western Electric continue their round-the-clock program of research and development, they are determined to keep America well ahead in the field of communications. And today they are looking, as all humanity looks, to the vast potentials of outer space.